Welcome to this lesson on levers, where we'll explore the fundamental concepts of torque and the fulcrum. Levers are one of the simplest yet most powerful machines invented by humans, and understanding how they work opens the door to comprehending countless tools and mechanisms we use every day. A lever is a simple machine consisting of a rigid bar that rotates around a fixed point. Its primary purpose is to multiply force and make work easier. Common examples of levers include wrenches, scissors, and fishing rods. Each of these tools uses the lever principle to help us accomplish tasks that would otherwise require much more effort. The fulcrum is the pivot point or fixed support around which the lever rotates. Think of it as the anchor that allows the lever to move. Without a fulcrum, a lever cannot function. The position of the fulcrum determines how the lever will multiply force and how much effort is needed to move a load. Torque is the rotational force that causes an object to turn around a pivot point. It's also called the moment of force. While regular force causes linear motion, torque produces rotation. When you apply torque to a lever, you create a turning effect that can move heavy objects with less effort. The torque formula is tau equals F times R tau, represented by the Greek letter, is the torque measured in Newton meters. F is the force applied, measured in newtons, and R is the lever arm distance, measured in meters. This formula shows that torque depends on both the force applied and the distance from the fulcrum. One of the most important principles of levers is force multiplication. A longer lever arm produces greater torque with the same applied force. This means that by applying a small force at a long distance from the fulcrum, you can generate a large force at a short distance on the opposite side. This is how levers make difficult tasks easier. The lever arm distance is the perpendicular distance from the fulcrum to the point where force is applied. This distance is crucial because it directly affects the amount of torque produced. The farther you apply force from the fulcrum, the greater the torque you create, which is why longer tools are often more effective for turning or lifting. When a lever is in equilibrium, the torques on both sides of the fulcrum are equal. This is expressed by the equation F1 times R1 equals F2 times R2. In other words, the clockwise torque equals the counterclockwise torque. This balance principle is essential for understanding how levers work in equilibrium situations, such as seesaws or balanced scales. Let's work through an example. If you apply 50 newtons of force at 2 meters from the fulcrum, what is the torque produced? Given that F equals 50 newtons and R equals 2 meters, we use the formula tau equals F times R multiplying 50 by 2 gives us 100 newton meters. This demonstrates how even moderate force at a reasonable distance can produce significant torque. Let's review the key concepts. Levers rotate around a fulcrum to multiply force, making difficult work easier. Torque is the rotational force produced by the lever, calculated using the formula tau equals F times R. Finally, longer lever arms create greater torque, which is why the distance from the fulcrum matters so much. Understanding these principles helps explain how countless tools and machines function in our daily lives.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.